think we stop here, working with data. Stop here.
Working with data.
We started here now.
Yeah.
Okay. We've seen how to import data, isn't it? Yeah. I think we've seen that. Read CSV, isn't it? So if you have the data in your directory, then that's fine, isn't it? Exactly. Isn't it? So we said, but of course there are many inbuilt datasets in R, and we started looking at the empty cars dataset. So once you call data, you see all the, without any argument, you see all the available datasets in R. And for the purpose of this class, we instead will be using the empty cars dataset, which is a motor, friend, car, road test. And a very horrid way of just seeing the entire data is just to print it. Just print the dataset, isn't it? But you know, although it is empty cars, you can decide to assign it to another variable, isn't it? For example, if you have let me say you have RStudio here. Yeah? Document. You know, although I can work on empty cars, I can just come and say print empty cars because it's already an inbuilt dataset. I can decide to allocate the empty cars to another variable, isn't it? If I prefer working with a known variable, so I can say empty cars, isn't it? And then whatever I want to do on the empty cars, I can work on the variable. For example, if I want to look at the first few rows, I can just do head data, isn't it? And that will show me the first few entries in that particular data set, isn't it? I know you can also do tail data to see the last few rows. Huh? So, of course, if you want to have a quick idea of the number of columns you have there and what variables they hold, you can use the summary function. Good morning. Good morning. Good evening. The summary function allows you to see a very quick summary statistics of the dataset. So when we do this, we saw the summary, and we saw that we can, of course, use our $sign to invoke any column that comes as a vector, and then we can apply it on any other type of function. For example, we can call the npg column from the empty cars dataset, and then calculate that. This will be a vector. And then we can be able to calculate the variance of that particular. You know how to calculate variance, Variance in statistics. We all know what it is. It's a measure of dispersion, isn't it? How dispersed is the data from the central value, isn't it? So if you have a variance of 0, what does that mean?
Close, I think.
As a data analyst, if you calculate the variance of a distribution of data, and you see that the variance is, for example, let me say, if I say x is equals to C 2, 3, 4, 5, and I compute the variance, of x. If I run this, that will give me a value 2.5, isn't it? I now ask that what if this value is 0? It means that all the data, variance in statistics is a measure of dispersion. It tells how dispersed the values are from the central value. If this were true, it means all the data are on the same point, isn't it? If you run this, you have 0, isn't it? Because variance, the formula is x minus x, the summation of it's the variance is the summation for all I for x minus what? X bar, isn't it? Squared all over what? All over n, isn't it? If it is the population variance, but if it is the sample variance, it will be what? It will be n minus 1, isn't it? So if the numbers are all on the same point, it means the difference, it means the mean is going to be the same, isn't it? For example, this value, the mean here, the mean is going to be what? Would be the same value because they are all the same, isn't it? The mean is going to be 2, isn't it? And if you say 2 minus 2 will be 0, 2 minus 2 0, then if you 0 squared, that would be. So not just computing stuff using R, you should be able to intuitively know what that is all about, isn't it? So you can compute the variance and then the standard deviation. You know the variance is a squared unit. For whatever unit, for the samples you are measuring, for whatever units they are, if you are taking the variance, it's a squared unit. So one way of getting the measure of dispersion in terms of the same unit as the variables you are measuring, then you simply take the square root, isn't it? So that's basically. Of course, you can do some amongst others, and we've seen how to also get some subset, get the subset of some data set, isn't it? Based on certain condition. It's very simple. From the entire data set, what do? You have your condition. You have your condition. So it's only where this condition becomes true that it returns the relevant column scope, isn't it? For example, in the empty cars data set here, we said we want to calculate empty cars where the HP column is what? Is maximum, isn't it? We said data, isn't it? So here, if you look at it, if I want to only get only the rows where the cylinder is 6, you can see that the cylinder can be what? Can be 6, 8, 4. I want to only get where the cylinders are what? Are 6. So that will be what? I'm listening. I want to only extract the data set for only the rows where the data column, the HP column, the cylinder is 6. So that will be what? I said data is. I said the data is nothing but the empty cars. Cool? Empty cars. So I now say data. Cool? Isn't it? Into bracket what? Data $, what? Seal, isn't it? Is equals to what? 6, isn't it? That's what I want, isn't it? And I want to get the entire row, isn't it? Isn't it? If I call this X and I decide to print X, I get only the instances where the cylinder is what? Is what? 6, isn't it? Now here it gives me all the columns. It gives me all the columns. What if I'm only interested in in a few columns? Maybe if I want to get the first column, if I put 1, that will give me sorry, I've not that will give me only the first column, isn't it? As a, if I want the second, to give me, sorry, it will give me what? What am I doing? Yeah, it will give me this one. This is apparently the cylinder, isn't it? If I want the third, it should give me what? What if I want this is the first and second?
Yes, comma, second.
1 column 2, isn't it? Prof, is that what is in your mind? I want to get the first and second column, so it will be 1 column 2, isn't it? Isn't it? And that will give me the MPG and the what? And the cylinder, isn't it? What if I come here and I say cylinder, seal? It only gives me a seal, isn't it? Now, what if I want to get, okay, let me get for everything. If I want to get the first and the fourth column only, 1, 4. If I do like this, it gives me everything. But I'm only interested in, let's say, the first, that's the MPG and the AM column. If you want to do them by numbers, if you want to do them by numbers, what will that be?
AM is 19.
This one, let's say MPG and which one did I say?
AM.
AM.
19.
So this will be 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be a vector of what? Containing 1 and what? And the 9th column. Go. Is that okay? It has to be a vector, so that it can only handpick the required one of MPG and column.
That's why comma, 1,
No, yeah, that's why we made it in a vector.
Put that C.
C denotes that we want to create a vector. Yes,
Sign.
yes.
1, 9.
1, 9. You know, earlier we said if we do MPG, it's going to give us only for the MPG. Go. So in the same manner, we can do MPG and what? AM. Go. And then we can put it inside the what? It will be also a vector, isn't it? We can just mention it, isn't it? And then it will also do the same thing.
So that's
two ways.
Yeah, true. You can either use the index of the column or the specific name of the column. So I think we've seen this quiz earlier, but who will remind us of the answer here? Fill in the blanks to find the rules from the empty cast dataset I think we've done all this now.
But me correlation.
Yeah, to remind me now, just to remind ourselves. This will be what?
MTCAS.
This should be MTCAS, isn't it?
Yes,
MTCAS $ MPG. More than, isn't it? Then comma, go. Yes. So working with data, we can use multiple conditions to find the rules that we need. For example, let's find the fastest car that has an automatic gearbox. So the QSEP column shows the 1/4 mile time, while the AM column shows the transmission type. And then we are able to do this. I believe everybody is clear about this. Treated it last. So in data analysis, you often find the correlation between two columns. So, and correlation is simply used in data analytics to find dependence between multiple columns. You want to find between this column and this column, how are they related? So a correlation value close to 1 shows that the compared columns are what? Are highly correlated. And while a value close to 0 shows that they are less correlated, isn't it? And you can find the correlation matrix using core function. This may not be useful to you, but for somebody who is into machine learning, if you want to develop a model, machine learning basically learns from previous data, and you use the previous data, the input of the previous data to now infer the output. So if two variables are correlated, then it can result into what you call redundancy. So you can decide to just drop it in. So you want to be sure that two variables within a particular data set are not entirely related. If they are related, then you can save one and then leave the ones that are entirely correlated. So how do you find the correlation matrix? You use this function, core. The core function, core, C-O-R. So for example, we have if you find the correlation matrix of the MTCAS values, it gives you, let's say, RESCO is equals to core MTCAS. If you run this, let's print it. So you can see that the numbers are too many, isn't it? So what's happening? Okay, then Control Z go. Then print RESCO. So you can see that the numbers are in certain decimal point. Well, if you want to round up to, let's say, a particular decimal point, you can just use the round function, isn't it? And then you can just come here and say res still equals to what? Round res to what? Let's say 2 decimal place. And then if you print res now, you see that it is what? It is 2 decimal place. So what does this mean? We just found the correlation between the columns in the MTCAS dataset. You notice that the columns are the same. Okay? The columns are the same, and then the rows are the same, isn't it? Remember, we said correlation tries to find what? The relationship between two variables. When you have a relationship of 1, what does that mean? It means they are highly, the perfect correlation, the ideal case is 1.
It's perfect.
Perfect.
Positive.
But close to 1 means it is highly correlated, and then negative means it is, if you have -1, for example, it means they are highly correlated but in a reverse direction, isn't it? So maybe when this one goes high, this goes low, isn't it? Or when this goes low, this goes high, isn't it? So Well, let's try to make meaning. From here, look at the MPG. Of course, MPG versus MPG is the same thing,
Yeah,
but
perfect
so that would be perfect correlation. But for, let's say, MPG and cylinder, isn't it?
No correlation, but negative.
No, that's no correlation, man.
Okay, 8.5, yes.
Minus
Negative
0.85.
it's strong negative correlation.
Yeah, but let's make meaning. Cylinder from the, what we said.
They cannot be compared.
Cylinder is number of cylinders, cool? And then MPG is the mile per gallons, cool? I think they're correlated, isn't it?
Number of cylinders. Same as mass per gallon.
Which
you say about the negative?
is this supposed to give negative? I can't either. No, but based on the data, it's still correct. It's negative.
No. Yeah, I can't about the negative.
Okay, because the more the number of cylinders in a car, the more the number of cylinders. What does that mean?
The
mile per gallon.
The miles per
Okay.
gallon.
Yeah, that's correct. So that's why it's giving us a negative correlation, isn't it?
This from again.
Here, we found the correlation. This one that we are doing is not just for fun. You can find a situation where you're analyzing the data, isn't it? And then you want to identify between this variable and this variable. Is there any alaka between them, or isn't it? Either to sieve out one or to look at the ones that has the higher. So this is it. We said, look at MPG, for example, here. Look at MPG versus MPG. The correlation is what? 1. Because the alaka between yourself and yourself is 1 now, isn't it? Yes. So, but the correlation between MPG and any other variable, you can see it varies, isn't it? The one that has the least correlation is the MPG and the gear, isn't it? So if it is positive, it means as this goes, it's direct, positive correlation. As this goes up, this goes up. As this goes down, this goes down. But for negative, as this goes up, this goes down, and as this goes down, this goes up. And then the strength or the relationship, the strength of the relationship depends on the magnitude of the correlation value, isn't it? Coefficient. If it is 1, perfect, 0.9, very good, then as you go down, when there is no correlation at all, that's when you have a value of what? 0, isn't it?
So this shows that numerically, from 0.5 above,
suggests strong correlation. Yes. From 0 to 0.5 suggests a correlation that's weak. 0 means no correlation.
So, sir, from where do you get this your data? Like, if I have my own data on Excel,
yes.
Because we normally run we normally run coefficient of correlation in most of our researches.
Yes.
Let me give you an example. Let's assume we're working on granules. So if you want to take your data from the field, maybe you can start by taking days to flowering. So you start counting the first days a plant starts flowering. Then at the end of the day, you take a data on number of leaves per plant, then maybe number of pods per plant, then at the end of the day you take plant co-crop yield.
Yes.
So if you run the correlation, you notice that the number of pods per plant and the crop yield, the correlation will be 1 or 0.9. Because the more the number of pods you have, the more the yield at the end of the day. So this is how we run our correlation.
Yes.
So let's assume I have my own data on Excel. So how will I pick my data from?
You import it now as a data frame.
Okay.
Simple. And then you call the correlation function on it. That's all.
In addition to what you said, with respect to the coding, for instance, we have like a rows and column, as he started mentioning it. So how can we write the syntax as you are writing from 1 to the end?
For example, let me create a data frame of the data you mentioned, isn't it? Let me say x is equals to data dot what? Dot frame, then open bracket. The first thing is what?
Serial number.
Serial number. Let's say 1 to 5, isn't it? Then number 2 is what?
Let's say number of leaves.
Rows.
The number of
Rows.
the number of, let's say this one is a serial number, isn't it?
Yeah.
It's equals to 1 to 5, go. Then what again? Number of
Leaves.
Leaves, go. Number of leaves, what? It's equals to, let me say it's a vector, isn't it? Let's say for the first one it is 2, second one 4, third one 1, fourth one 6, then isn't it? And then let's see what again, another variable. Number of ports, what? Number of ports, then it is equals to what? Let's see, also a vector, isn't it? Because you can only find the correlation between the numerical values, isn't it? So you have what? Let's say 2, 3, 2, 4, isn't it? Yeah? Chicken? 2, 3, 2.
Let's say give any other number, maybe 3 again.
Okay, 3 again.
Along with the number.
Okay, so let's have one more variable. Plant height. Okay, pH. Since we have many biology people here. pH. Shima is a vector. What?
So
let's see. She wanna should float back. 2.3 ko? 2.3, 15.4. Then what again?
9.7.
9.7.
Can say 10.1, something like
9.7, then 10.1, isn't it?
that.
Is it okay?
Let me count.
9.7 and 10.1, isn't it? 1, this is 5, this is also 5, this is 1, 2, 3, 4, and then 12.5, isn't it? Yeah? Isn't it? We can have our data frame now, isn't it?
Yes.
This is our data frame, isn't it?
Yes.
So very simple. You have how many variables?
3. Yes, 3.
Even though here we have serial number, which may not
It's not
make
like
sense. Right?
it's
So,
3.
but you can just see core what? Core X. So you can see between number of leaves and number of leaves, it is what?
Okay. 1.
From the number of leaves and number of leaves is 1, isn't it? And then the number of leaves and the number of pods, you can see that it is very strong, isn't it?
No.
And then from there you can make your inferences, isn't it? It depends, you are the master of your area. If you want to drop any variable whose correlation is above certain value, you can do that, isn't it? For example, sir, for this data, if I say check for the correlation, if it is more than this, drop something. Like, yeah. No, but that's just it now, eh?
So in addition, for instance, we used to have like a parameter, like you have like some parameters from 20 to 30. Does that mean that you need to be measuring each of that parameter? Like the one we mentioned, 45.
No, one you're just doing it for illustration. No? But if you have an Excel file, for example, if you have an Excel file, you can comfortably come here and do your data, isn't it?
Yes.
Let's say number of leaves, go. Then 2, 3, 5, blah, and then whatever you have here. 1, 2, 3, whatever. Huh? Huh? So if it's like this, you can even have missing values, isn't it? Hmm? And if you import them, they will come as NA, isn't it? In the data frame, isn't it? Hmm? But if you are creating the data frame directly on R, then it will require you to specify that they have exactly the same. I don't know whether I'm answering the question. No, you can cast it again.
For instance, from column A, let's say the data will be like from column A up to T.
Up to T. Okay, yes. Up to this place.
Up to the ST.
Okay, S here.
All is filled with the data.
All here is filled with data.
Then up to maybe where you stop now.
Yeah.
So now, if you are going to make a correlation, like you are mentioned something like, the variable they are 5. No, they are 3.
The variables?
Yes.
What do you mean by the variables are the number of columns?
No. What I mean that number of waves, the plant height,
okay.
No, they are 3.
For mine, but
yes. Then we are mentioning we are taking parameter of each of that one up to 5. So this one, let's say for instance we have 3. So I want to run against that up to T. You understand? For instance, let's say for instance, let me take soil.
Okay.
We have like a pH, calcium, magnesium.
pH, calcium, magnesium, potassium, sodium, nitrogen, phosphorus.
Kuma me ne bi kwa cika sai ai magana.
So we have this.
Yes. My question, all is filled with the numbers.
Everything here is filled with numbers.
Yes. Up to that 21. You just assume any number.
20 go.
21 yes.
The same thing with that here.
Yes,
so I remove that minus.
Why?
Sometimes with the value.
Okay. Okay.
Something is that.
Yes.
So you also extend it to the next one.
To where?
Yes.
So I pick here.
Vapi. Okay.
So for this one, before you are mentioning like 2, something up to that 5.
And that's it now. For null we have 2, 3, 4. As well, no.
The last. Then there's something with that one. So for instance, while we have more than 5, let's say for instance we have like this one.
Which one?
They have more than 5. Up to that T, ST.
Okay, now they are 1, 2, 3, 4, 5, 6, 7, 8.
Up to that T.
T,
Just like replicate them at different levels. So how can I make that correlation with that one?
It's the same procedure.
Sir, you are mentioning comma, this is mentioning comma.
The commas are the values here now.
Sir, can I?
Okay.
Maybe they understand the issue.
Okay.
I'm sorry, I missed some classes. I don't know whether you explained in the previous classes or not. Okay. Assuming I have a large set of data, just as he's trying to see in Excel. Now I want to go on with my analysis. How do I import it into the R programming?
Import CSV. For example, we have. Let me have Yusuf. I think I want to share the data with you. Go. Let me go to my documents, isn't it? I think I have this my file. Go. The downloads neighbor. Documents. Go.
Got to turn it.
Let me say this data, isn't it? This data, Barashiva? This data here, isn't it?
Yes.
Let me rename it as Let me rename this data as
Yeah,
is that okay? Let me rename this as my file. Go. The assignment I gave you, isn't it? My file, isn't it?
But it's not showing.
It's not showing? On P. Duplicate. Go. This is my file, Barashima.
Yes, sir.
This is a normal file that you can open your
Yes,
computer
yes,
and type. Huh?
Yes, sir.
So what next? What do you want? You want to carry this file into R. You miss our class.
Yes, I mentioned it.
So it's really
The same thing is
And
happening.
it's the same
Yes,
because
yes.
if we can import this, definitely
There is no need of creating a data frame 1, 2,
it's two questions.
Okay.
How can we import it?
Yes.
you understand now.
I'm
Then they
actually
ask you to make
right
a coding.
This is it now. This is
Yes,
what we
what
start.
did
This is where we started in the class. We said if you want to import any data, this is it. Are we here now? Sorry. Let me put it in slideshow first. F5. Go. This is where we started. And you're in the class.
Yes, I even asked that question.
I
Just
don't-
like this one.
This is
You
it
know,
now.
we are
This
making
is
it.
the, unless if maybe,
I even asked the question that.
this is how we carry data from our computer into the R interface.
Yes.
Sir,
This is my file. This is my file, but
Yes, sir.
this is my file now, isn't it?
Yes.
This is my file. So you just go there, but you know I'm working in a different directory here, isn't it? If I say get working directory, it says I'm in the documents folder. So one thing, and I think I've explained this, is either you copy this guy and then you take it to your document and you keep it there because that's your working directory, isn't it? My file, huh? And this is CSV file. And then you use this code. Data is equals to read.csv, then the name of the file, isn't it? So you don't have to type this one back. Your data is already in this in Excel. You have it now. So you say data is equals to read dot what? CSV. And then you supply in the name of the file. Huh? The name of the file is what? My file, isn't it? My file, huh? Or CSV. And if you run this, the data has already been imported, isn't it?
Yeah.
And you can come and print the summary. Print the data, enter. Is that okay? This is it. Or you can even come and so for example, if I decide to do get the correlation of this data, well, let me do the summary first. Summary of the data, cool? It tells me that the passenger ID is a numeric value, isn't it? The survived is a numeric value. The passenger class, it's a ship. I think this is a Titanic data set. Just like your plane, economy, first class, exactly. So this one are the names, cool? This one are the gender, this one are the age, cool? This one are the siblings, blah blah blah. So if you do correlation, you're only going to get the correlation between numeric columns, isn't it? So if you do core data now, what happens? Core data. So you see what happens? It says
X must be
the data must be what? Must be numeric, isn't it? But if you can have a data that's entirely numeric, then you won't have any problem.
Or you just set extra
Okay,
for the
so let's do that.
May I have the data?
let me do CSV. Okay, let me say Excel, so that I can open. The first one is cool. One is entirely numerical, cool. Passenger ID, isn't it? Yeah. This one is entirely numeric, isn't it? Cool. And then what again? Survive is also numeric. And then passenger class, Shima is numeric, isn't it? Huh? And then what again? You see age, go. Huh? Some are not a number, isn't it? Okay, don't worry. Passenger, this is what? For example, so we have this comprehensive data, isn't it? But because we just want to see a few of it, isn't it? Let's assume we have something like this. See. So that we have a manageable number because it's very plenty. Isn't it? Let me just make it like this. This is your data, isn't it? And then you save it. Let me save it in the document. In the document, let me call it MD, yeah? And then I'm saving it as a CSV file, isn't it?
Yes.
Because I'm using read.csv. In R, if you want to read Excel, then you have to use another library, isn't it? CSV, comma delimited, isn't it? And then you save this, isn't it? So in my document now, I have the MD data, isn't it? So I can come here to my R environment, and I can what? I can say data is equals to what? Read.csv. What do I want to read? MD dot what? .csv. And if I run this, you see that the data has been imported, isn't it? That data I can come here and print it to see it if I want to see it. Is it back? Yeah. And if I want to find the correlation between the data, I can simply come and say cor this, isn't it? And then you can see the correlation. It's clear now?
Yeah.
Very clear.
For example, the data we initially imported was placed and contains numeric value and non-numeric values. Is there a way in the studio where we can extract?
Of course, you can
columns
do that, man.
so that we can check the correlation?
Hey, man, you can do that, man.
Without going back to Excel.
For example, we are going to see how to handle missing values and not a number. So you can write a simple code to check if or maybe if it's a numeric value, isn't it? You can just do some math operation. If it is valid, then you can select it. But of course, if you're finding correlation, then you should have the specific columns you are interested in, isn't it? And then you can write a simple slicing operation that can select the columns of choice, isn't it?
Yes. That commerce like the one that just went, okay. if our data in document is not a CSV file, it's an Excel file. For example, it will be my file.xlx.
Yes.
So if you copy that data,
But you have to import. You have to get a library specific for. We are going to come to that. Excel is not a legacy file in generally in Windows now, isn't it? If you install Windows 10 or Windows 8, you have to install Office before you can see XLSX, isn't it? So there is a special module that is used for handling XLSX files. That's the Excel files. But for the legacy ones, the CSV. We are going to come to advanced data handling where we expose you to some of this. So you simply import a library, and then once you import the library, then it will allow you to, if you go to your RStudio now, it depends on your version of RStudio. Sometimes it's already there. Let me go to Excel. Okay, Excel. See if so fingership. So in that case, you're not going to use read.csv. So they can find the read.excel, isn't it? It's a special module for handling Excel file, isn't it? So you read_xls for reading Excel files. So in that case, you not use read.csv. But this one is just for a second. Somebody may say he wants to read a Word document. How can he do that? Then it's your duty to now go and look for a secondary library that will allow you to do that, isn't it? But they're going to expose you on how to manipulate libraries. It's clear? Partly.
because like our normal documents for our data, it's saved in Excel, it's going to come in XLX.
I know. That is, I know. I know. That was why I saved it as CSV.
Okay.
Because this, for now, this slide is teaching you how to read CSV files. Even though you can open CSV files in Excel, isn't it? But if you put Excel here, .xlsx, the read.csv function will tell you, I don't know what, I cannot read this type of document. So you have to convert that your Excel file into a CF. Let me see if I have any Excel file here. One is CSV. Go. This same file, let me open it. Okay, that same file that we have in the document. Go. Where is it? MD. Go. Let me open it and save it as Excel. Let me save it now. Save as. Let me say in document. Let me say MD2, isn't it? And I'm not saving. I'm saving it as what? As Excel workbook, isn't it? Now, if you go to your document, you see MD2, isn't it? This one is the Excel file that you know. If you go to properties, you see that it is what? It is XLSX, isn't it? And if you open it, it's your normal Excel file, isn't it? It's already open somewhere, so let me just close it. So if I open this file, this is your normal Excel file. You can come and do Ctrl+D, bold this one, put some colors, and do whatever thing you want to do, isn't it? This is your normal Excel file. If you want to read this now, and you come here and you say, if you say data is equals to read.csv, and then you read that md2 dot X LSX, isn't it? And you hit enter. It tell you, okay, I cannot read this type of file. I can only read CSV files. Well, so if you come here and you convert it to CSV, of course there is no such file. One way is just to come here. That's the lazy way. Is to come and say file, save as document. In the document,
Save as type in so that MD2.
no, okay, now MD go MD2, but in this case I will now save as CSV. So now it's a CSV file, even though it will look like an Excel file, isn't it? If you go to MD2, you see it, isn't it? This one is the MD2, but this one is the Excel file. Where is the one that we saved? This is MD2 dot this CSV, isn't it? If you open it, that the CSV does not support all this color and, isn't it? That's the legacy of CSV. The CSV is like the notepad version of Word. You know notepad now? Especially in the copying. If I have a Word document, or maybe you copy something from online, isn't it? Anything. Let's say this money, and then you copy this guy. One of I is in. If you copy this and you put in Word, it will retain the formatting code. This one is emboldened. This one is not. But if you paste the same thing in Notepad, it will only keep the legacy words, but it will not put any. Even if this is in italics, Control I, Unai Shikato, and Nazunasa Wani color. If I copy this and I take it to Notepad, what happens? It only retains the normal font. So what I'm saying is that if you want to work with CSV files, you have to use the read.csv, and then even if your document is in Excel, like for me personally, if I'm working data analysis, I don't bother. I simply go and convert the Excel file to CSV and then read it. But if you really want to leave your Excel file where it is and import it as then you have to come and use another library, which I said, like the read XLS. And this one is not even default. You have to install another module first before you do that.
So I don't know if this command as read the CSV. What if we use read.xlsx and then we call the file?
It will work. The file, the read.xls does not exist. XLSX, XLSX. To tell you, I don't know, could not find this function.
Does that mean this CSV is like it's common to all data matches if we are using for analysis? Because SAS
okay. Yeah, because it's the basic file format for handling tabular data in all operating systems. Yes. So let's continue. I think. So that you can cover a few. So we can do this now. So we should also learn how to group data. How do you group data? R allows us to group data by a column and calculate an aggregate for the group. You have a data. If you want to group a data based on a column by a column and then calculate a certain value, you can do that. For example, let's say that we want to find the average horsepower of our cars, grouped by transmission type. I don't know whether this is making sense. You know, if you want to find the average horsepower, what will happen? It will be mean of AVG, mean of empty cars, $HP, go? So we now said no. We want to actually find the average horsepowers, but we know that we have a transmission type, go? What and what? Manual and automatic, no? Let's group the cars into because it will not be fair for you to get the average horsepower of all types of car. But it is better you group the manual cars separately and then the automatic cars separately, and then you can now find the average horsepowers of the manual cars and the automatic cars. Even though based on your knowledge now you can be able to do that using your first principle knowledge, isn't it? But there is a more elegant method of doing that using the by function. So the by function allows you to group a data set by a particular column and then find anything you want to do based on that demarcation that's given you. So what happens here? So it's a function, and we know every function requires what? Opening bracket and the closing bracket, isn't it? So it applies a function to each group, isn't it? So what happens is that, please help us group the cars. Please watch this. This is very important. By something. By something. So it's saying apply this third function on this grouped by this. Is that okay? Apply this on this grouped by this. Okay? So now we are going to get the first thing to do. The first thing you want to do is to what? If you have to do it manually, maybe say I want 6 lines of code here, isn't it? Abi? If what you want to do now, you have to do like 6 lines of code. You want to get the average horsepower of manual cars and the average horsepower of what? Automatic cars. Yeah? If you have to do that manually, what will happen? The first thing is to say data is equals to what? Empty cars. Go. Then the first thing is to arrange the data by what? Let's say manual. Go. And then the manual is what? It's either 0 or 1. Go. So let's say data 1 is equals to what? Data, open bracket what? Data $, what? AM, go. The $. Did we import the? Okay, we've not run in Nego. Isn't it? So you say data $, what? AM is equals to 0. Go? Isn't it? How can it go? You see, this one will only give us, it will only give us, if we print data 1 now, if we print data 1, it's only going to give us what? Cars masu automatic, right? And then we now want to find the average of what? The average of this guy, of the HP, isn't it? So in that case, it will be now print what? Mean. Which data? Data 1. Data 1, because it's the one that we have already $, what? HP. This is going to give us, let me if you run this now, it's going to give you 160.2632. If I want to do for the automatic, sorry, or for the manual code, it will be what? I can just come here and say this is data 2 code. Data 2 is equals to, when it says 1 code, and then we have this data 2. And if you run this, we get, for the first one, we have 160.2. So the average horsepower of automatic of zero is manual, right? So the average horsepower of manual cars is 160, and the average horsepower of automatic cars is what? Is 126. We now said this 1, 2, 3, 4, 5, 6. We can do it in a more elegant way. We can just say, arrange, find the mean of the empty cars by horsepower, arranged by what? By AM. Is that okay? So you can just say by maybe data, $, we want to find the average of HP code, isn't it? Grouped by what? Data, $, AM bar. What do you want to find? The mean code. And if you do this, you are going to see that the first one is 160, and the second one is what? It's clear? Yes. If you want to find the maximum horsepower for manual cars, that's among the manual cars, which one has the maximum horsepower, and amongst the automatic cars, which one has the maximum? Just be max here, isn't it? Max, isn't it? And it gives you, okay, the one that has is 126.84, and then this one is what? 335, isn't it? And for the, if you want to get the mean, you get 62 and then 52 respectively. So this is it. So fill in the blanks to import data from the people.csv file and select the rows that correspond to the age with, everybody can do this now, isn't it? Fill in the blanks to import data from the people.csv file. Select the rows that correspond to people with age greater than 18 and output their average height. So what will be here? Read. This would be read. This would be read. Please don't mind my handwriting. That's not how it is in real life. Read.csv. So what do we want to do? We've imported the file code, and then select the rows that correspond to the people with what? Age more than what? 18. So here will be what? Age. So it means there is a column that has what? Age. Age here, isn't it? Greater than, and output their what? Their average height. So this will be what? Mean code, isn't it? Data 1, $, what? Height, देखो, average height, go. And then you print what? Yes. So this is another one. So the solutions are there, cool? Please, because of the timing, I don't think we should, but you can just solely fill in the blanks to find the cars in the empty cars dataset that have MPG greater than 20 and output their what? Smallest weight. Yeah, dynamic coding. So, that have MPG, this MPG go? Greater than what? 20. And then output their what? Smallest weight, isn't it? So, mean go? Weight go? And this also, the Titanic survivors dataset, titanic.csv, given to you. I've not given it to you, isn't it?
Yes, given
I
to
think
you.
I've given
It
you.
has been shared to me.
Okay. Includes information on the passengers of the ship. Assuming we want to understand how the class of the ticket impacted the survival rate, find and output the mean class value for the passengers who are adults aged greater than or equals to 18, grouped by what? By survived column. So this is the implementation, isn't it? So the first thing is to read this Titanic file, assuming that it's in the same directory. And then the next thing is to get only adults, isn't it? And then this is the age. From the Titanic data, we get the age column that is more than 18, isn't it? This will only give us the samples that are adults, isn't it? And then what do we want to do? We want to separate them, isn't it? We want to find the mean value of those that survived, right? But we don't want to find the mean of everybody. Those in economy, for example, how many survived? Those in first class, how many survived? So Shima, the ship is into categories, isn't it? So we want to first of all use the by function to group them by what? By survived, right? And then find the mean of what? The passengers class, isn't it? So, and if you do that, it's going to give you the answer. Before we go to visualization, I just added this recently. It may not be in your these are because I gave an assignment and some people are saying that more than 90%. Somebody said more than 90% of what was asked has not been covered. But that's a lame question actually. You know why? Because in the actual learning is in challenging yourself to go beyond what was taught in the class. Nobody can teach you R from beginning to end. Nobody knows. Even me, there are some functions that you can even know that I don't know. But with the little knowledge you have, you should be able to explore and then play around with several things, isn't it? If you're given a task, I'm back on a job, like 1 million naira, and you're required to do something, will you call the lecturer or? No, it's your duty to go and find ways. Okay, how can I do this? Isn't it? And then of course, even if you have the answers, you know how it is done. So you can check for missing values in a particular data set, isn't it? And there's this function. Is NA in R means what? Means something that is missing, isn't it? So if you want to find the missing value, you use what? Is NA again? The is NA is going to return all the columns where there is nothing. For example, if you come to, it's a function as you can see, so you simply supply in the data frame to it. So if you come here and let's see, where is our data? Let me see, my data is what? This data, right? So look at it. If you say is NA, it's like a question, isn't it? Like it's a question, and then you supply data, isn't it? It only returns instances where there is what? There is a missing value. Musali yanzu kaman, let me go to that let me go to, we open our file, what, MD2 go? No, the one is CSV. MD1, what? Look at it. Musali, let me delete this guy, isn't it? And then let me also delete this, isn't it? Huh? Hmm? Look at it. If you do something like this, for example, isn't it? This MD, and then if you come to your R, and then you do data is equals to read.csv, what? MD, md.csv, isn't it? And if you print the data now, you can see that in the bubble number where we deleted is coming as what? As NA, isn't it? So if you want to check a data frame to see where there is a missing value, you can just come and say is NA is not a number? It's a question. So it returns a boolean, true or false, isn't it? And let's say data. So dig in there, wherever there is a missing value, it returns what? True. True, isn't it? True. Is that okay? And of course, you can even count the number of missing values, isn't it? If you do sum, is NA, it will tell you how many missing values are there, isn't it? If you come here and you do sum is NA, it tells you that there are four missing values. So, for example, you know that if you're doing your analysis, if you do core data, you can see that in the missing values, the something will not be able to do that, isn't it? And let's say you want to maybe do something on the missing values. So there are several things. You can decide to say, okay, replace missing values with the mean of the what? Of a particular column, isn't it? So you can say, okay, data for a particular, maybe if you want to carry a particular column, you want to say data $ score. Score should, maybe we are assuming that it's a column in your data, isn't it? And then this is not a number, it checks what? It checks whether, this returns true or false, isn't it? This returns true or false. So you want to now replace wherever we have this problem with the mean of that particular column, isn't it? But of course, if you're taking the mean, there is a what? There are not Sally as well. This column. And there's no missing value, isn't it? The survived now. If you want to find the mean of survived, you do data $ survive, mean data $ survive. But if you do that, you're going to get error, isn't it? Because there are missing values there. So that's where this particular function comes handy. This not a number dot remove. So you're saying I should remove not a number, then you say true, isn't it? Not a number dot remove. For example, let me say Where is R? If I say data $, what? Survive, nego? Survived, what? If I say find the mean of this guy, it's going to be what? Why? Because I'm the same value actually. But if you come here and say, please find the mean, Amankaga not a number, a chirishi. Oh? And you said yes, true. Then it's going to calculate the mean of only the numbers that are not there, isn't it? That are there that have not been. So now what if please